Ceres is the largest object in the asteroid belt between Mars and Jupiter. It's also the only dwarf planet that is located in the inner solar system rather than beyond the orbit of Neptune. Its name comes from the Roman goddess of corn and harvests. Ceres was the first member of the asteroid belt to be discovered. It's also the first and currently only dwarf planet to be orbited by a spacecraft. That spacecraft was part of the Dawn mission, and it arrived at the planet in 2015. For many years, Ceres was known as an asteroid, but it's so much bigger and so different from other objects in the asteroid belt that it was reclassified to a dwarf planet in 2006. Just by itself, Ceres comprises up to a third of the mass of the entire asteroid belt. Pluto is still 14 times more massive than it though, so there's a pretty big gap between them even though they're both dwarf planets. Ceres is one of a few places in the solar system where scientists want to search for signs of life. There's evidence that it has water, which is crucial for life as we understand it. If there's anything currently living on Ceres, it's probably some small microbes similar to bacteria, but if there isn't, then there could still be signs that life was once there. In the late 18th century, astronomers became convinced that there was another planet between Mars and Jupiter. This conclusion was based on the Titius-Bode law, which describes an apparent pattern in the spacing of the orbits of the planets in the solar system. The law predicted a planet in the wide gap between Mars and Jupiter. In 1801, Italian astronomer Giuseppe Piazzi discovered Ceres. He assumed it to be the missing planet between Mars and Jupiter, and so this newly discovered body was accepted as a planet. Within just a few years, Pallas, Juno, and Vesta were also found within the same region. Together with Ceres, all four were considered planets, but in the 1840s, astronomers began to discuss reclassifying these objects. They didn't really fit the definition of a planet. They were far too small, and unlike Mars and Jupiter, they couldn't even be clearly seen through a telescope. By 1860, a total of 62 bodies had been found between Mars and Jupiter. By 1863, astronomers accepted all of these objects as asteroids and called the region the asteroid belt. Thus, Ceres changed from a planet to an asteroid. Then, almost a century and a half later, Ceres was reclassified again to a dwarf planet. This happened around the same time that Pluto was changed to a dwarf planet. Because Ceres fit the criteria that was put forward to define a dwarf planet, it was reclassified. Ceres came to be alongside the rest of the solar system about 4.5 billion years ago. Gravity pulled a bunch of material in the swirling disk of gas and dust together to make the dwarf planet. Ceres is sometimes described as an embryonic planet. This means it began to form a larger planet, but it never completed this process. The strong gravity of Jupiter is probably the culprit behind this. In fact, Jupiter is most likely the reason nothing in the asteroid belt became a planet. About 4 billion years ago, Ceres settled into its current location. It floats among the rest of the asteroid belt, a bunch of leftover pieces between Mars and Jupiter. At its furthest point, Ceres is 277 million miles from the Sun. At its closest, this shortens to 237 million miles. This makes for an overall average distance of about 257 million miles from the Sun. At this distance, sunlight reaches Ceres in about 22 minutes. Ceres has a pretty long orbit. It takes 1,682 days, or around 4.6 Earth years, to make one orbit around the Sun. Its rotation is much shorter at just 9 hours. Additionally, its axis of rotation is tilted just 4 degrees with respect to the plane of its orbit. This means it spins almost upright and experiences no seasons. Ceres has a radius of 296 miles, which is a mere 13th of Earth's radius. It has the shape of a flattened sphere. This means the diameter at its equator is longer than its diameter between the poles. Because of its small size, its gravity is only about 3% the strength of Earth's. Although it's the largest body in the asteroid belt, it's not the brightest one. That honor belongs to Vesta instead. In many ways, Ceres is more similar to the terrestrial planets than to any of its asteroid neighbors. However, it is much less dense than the terrestrials. Ceres has a layered interior, but its layers aren't very clearly defined. Its core is probably solid and surrounded by a mantle of water ice. As much as 25% of the dwarf planet could be composed of water. If this is the case, that would mean it has more water than Earth. The crust of Ceres is rocky and dusty, and it features large salt deposits. These salts aren't like the one you put in food. They aren't table salt. Instead, they're made of different minerals like magnesium sulfate. Ceres is a very cold place. In the daytime, its temperatures range from -136 all the way up to -28 degrees Fahrenheit. Nighttime is even colder, averaging around -225 degrees. In terms of composition, the surface of Ceres resembles the carbonaceous chondrite meteorites here on Earth. This surface is covered in countless craters, many of which are small and young. None are larger than about 175 miles in diameter. This is surprising because over its very long life, Ceres must have been hit by numerous rocks. This lack of craters can be explained by layers of ice underneath the surface. Features on the surface could smooth out over time if ice or another low-density material like salt is just beneath it. It's also possible that past hydrothermal activity, such as ice volcanoes, erased larger craters. Ceres is not believed to have a magnetosphere. It does have an atmosphere, although a very thin one. There is evidence that this atmosphere contains water vapor. This vapor could be produced by ice volcanoes or by ice near the surface sublimating. In 2015, NASA's Dawn spacecraft arrived at Ceres. It had already visited the asteroid Vesta by this point. While it approached Ceres, the spacecraft imaged a bright spot on the surface. As it grew closer, this spot resolved into multiple bright patches. These are known as Cerealia facula and Venalia faculae. Upon closer inspection, Dawn observed hundreds of bright patches on Ceres. This puzzled planetary scientists. Could these bright patches be areas of exposed ice? When Dawn arrived in orbit and took clearer pictures of the bright spots, the largest area of them was found within a 57-mile wide crater called Ocketer. It turned out that these bright spots are not ice. Instead, they're mostly sodium carbonate that was left behind by briny water that rose up to the surface before sublimating. The water came through fractures that were left behind when the Ocketer crater formed about 20 million years ago. Data from Dawn suggests the briny water originated from a reservoir about 25 miles beneath the surface. The sodium carbonate deposits were first left behind about 9 million years ago as cryovolcanism brought the liquid to the surface. The process appears to be ongoing. Dawn detected water still within the sodium carbonate deposits. Because water should sublimate quickly when exposed to the vacuum of space, in order for Dawn to have detected it, there must be something replenishing it. The presence of water means it's technically possible for life to exist on Ceres. It's not very likely because of the high salt levels and low temperatures, but it can't be ruled out. Alternatively, life could have existed in the past when Ceres was warmer. The Dawn mission concluded in late 2018 when the spacecraft ran out of its hydrazine propellant. This meant it could no longer point its solar arrays at the sun to generate electrical power, nor could it aim its antenna towards Earth. The mission was considered highly successful, and to this day, the spacecraft remains in orbit around Ceres. Ceres is a very interesting little object in the solar system. I think it's pretty neat that it's the only dwarf planet not beyond Neptune's orbit. It was the first dwarf planet explored by a spacecraft and still the only one to be orbited by one. It's a little funny how Ceres went through so many classifications too. First it was a planet, then it was an asteroid, and now it's a dwarf planet. It's a good example of how we change the way we label and talk about things as we learn more about the universe and our solar system. I hope you enjoyed learning about Ceres. I plan to eventually have a video on all of the other dwarf planets in the solar system. I just gave Ceres its own video because we know a little bit more about it than the others since we've had a spacecraft orbit it. So stick around if you're interested in learning more about the other dwarf planets. Thanks for watching, like and subscribe if you enjoyed, and have a good day.